All right. We're coming to the end of stuff. So let's finish for now talking about sockets and server sockets and how to make a client server connection in Java. And then let's relate that to PA5, and then I want to talk about threading. And you can get most of the legwork done for PA5 already, but to actually make it work well, we're going to want to do some threaded programming. And so we'll come into that, but I want to finish up sockets first. So PA4 was good. So lots of games that worked completely well across the board. Lots of different designs, which was cool to see. Different interaction mechanisms, things like that. I saw a lot of creativity in how people convert XY coordinates into rows and columns and edges. I saw people using nested loops and incrementing X and Y coordinates and looking for a spot where your mouse coordinates correspond to these incremented values, things like that, and stuff like that. So if you weren't sure how to dial in PA4, how to translate mouse coordinates and so on and so forth, come by office hours and let me know. Let me take a look at something. I think I got a grade for someone else's work on mine. I can stick around a minute after class if you want to ask me about that. Okay, cool. I'll try to remember to do that. What else did I see in there? Mostly I just graded straight from the rubric. There were a few cases where, for example, after typing in someone's name, I had to hit the enter key for it to actually register, and if I didn't stumble across that, then it might have looked like initials weren't working correctly or things like that. Probably the biggest trick seemed to be, figuring out where a click was relative to a line. So if you click right here, how do you know that it's this line that's trying to be filled in? A number of people highlighted whichever line your mouse was close to by using the mouse motion listener, and that's useful for debugging, development, and also, when you're playing to know which line you're about to claim. Definitely, if you click right here to claim this line, you've got to go into the box on the other side of the line and also set that thing's Boolean. And in some cases, if you had 3 lines here and then you click the mouse right here, if you don't do that, you'll see a line here, but you won't see an initial in here because this box's bottom Boolean isn't set. So things like that. Mostly just dialing in details, but even in cases where the score was lower than it might have been, it looked like the core behavior was working. You were picking up events correctly, and mapping to rows and columns and usually edges. So if you didn't finish it, right, definitely come by and let's talk and let's get this cleaned up and finished so that you can build on it for PA5. PA5 is just another layer put on top of this. So that's much more doable once you've got PA4 where you want it. So any other questions on that or anything else? I wanted this hardwired for an 8x8 array of boxes, which is a 9x9 array of dots. and I said, you know, don't hardwire magic numbers. Don't pepper your code with the number 50, you know, in a dozen different places. Put that 50 into a variable and use that variable in your code. But about half the submissions seem to have the option of changing the grid size, which is a cool option, especially if you can make it smaller, so that you can play to the end of the game quickly. But in some cases, you know, people's codes seem to be broken by trying to have a button to like make the grid, you know, more or fewer dots, and so on. And you definitely don't want to sacrifice core functionality. So yeah, make them variables, but that doesn't mean you need a GUI interface in order to change them. So maybe I gave the wrong impression on that. But yeah, I just meant don't ever pepper your code with magic numbers, because if you make these 50 by 50 and then you decide that, you know, you want to make them 60 by 60, you could go through and blindly replace every occurrence of a 5 followed by a 0, you know, with a 6 followed by a 0. That's not going to work, because your whole field might be, you know, 450 and now it will become 460. So usually magic numbers, you try to put them inside variables, right, or, you know, fields in a class, and then if you want to change the board size, right, you can just change that one spot. That's just kind of a general practice to have. Check something. All right, anything else? If you did not get a grade on PA4, you have to come talk to me today, and we have to go over some stuff. So, and if you think there's an issue with the grade you got, or the points don't add up or something, definitely come by and talk to me. All right, well, let's go on to server sockets, so, and sockets. So if we just think about one client and a server, right, we know that we can create a server socket with a particular port number and a particular address. And been using Telnet as our client, and we could say make a Telnet connection to this address, this port number, and we could touch that socket and then send information back and forth. And so we did some examples of this. Give me one sec. All right, so here was our server code, which made a server socket port 1234, which happens to be the port you want to use for PA5. So construct the socket inside a try catch, and then call the accept method. And accept will basically hang out, wait for a connection request. It will accept that connection request, and that means that this creates a new socket over here and a socket here, and basically connects those together. so that you can do this two-way communication. And so if we run this, and then you make a connection to port 1234, we get this two-way connection set up where we can send over here and send stuff to the server. Now there's nothing on the server side that's reading from standard in, so nothing is getting sent back. But potentially this is a two-way connection, and then when the connection is shut down, in this case by the client, it closes, it says connection gone, and then you can see the stuff that I typed was buffered up, and so that comes out to bash. So the other side of this is, the telnet side, that's the client side. And we can code that up just by using the socket class. So ServerSocket creates a special kind of socket that is bound to a port number and then can accept connections. And remember, the ServerSocket, when we call the accept method, it returns an object of type socket. So in this case, sock. So we can also just create a socket by ourselves, and we can specify a host address and a port number that we want to connect to. So we can build both ends of this this setup. So let's write that. So let's create a plain socket. So let's look at the constructor for our socket. So inet address, which is an address, I don't know if that's going to work or not. I'm kind of blanking. Yeah, it's not going to work. Okay, that's going to work. So let's just try this. So I'm just going to create a socket on the local host at port 1234, and let's see if we can get a connection going. So there's our server running, and if we run the client, it goes ahead and it says, hey, we got a connection request from localhost on this port number connected to port 1234. Yeah, thank you. All right, so we can create a socket, we can connect it to a remote machine, and then let's send some stuff out into that. So let's make a print writer. So we'll make a new print writer, and we'll construct it from socket.get output stream. And we'll just throw a message into there. So we'll print a test message. We'll close our print writer. We'll close our socket. So all the stuff that Eclipse would do for me if I wasn't too lazy to fire up Eclipse. And so I'm going to do what I told you not to do, which is I'm going to be lazy. And I'm just going to throw all of this inside my try statement. Alright, so we run our socket and it pushes that message out through the socket, and our client receives it and printed that out. Let's see, Matthew said that connecting a local machine to a VM might be pretty tricky, but could you talk about why? Would you need to have a real server somewhere? That's a good question. So you should have legitimate addresses on your virtual machine. But let's see what this does. Boy. All right. Let's see. Let's just try this with a server. And I didn't set this up. Okay. Hold on a second. I forgot this was a totally new machine I built just for firing up Eclipse. So I don't have clipboard sharing and stuff set up. I don't even know if I have, yeah, I must have Java on here. Alright, so that works the same. So I can still get to this as 127.0.0.1. And if I do the if config, I got 10.0.2.15. And so maybe I can get to it like that also. Alright, so that's its machine address on my VirtualBox. So, but it basically works the same as usual. And I think I'm 192.168.0.101. So if I run the server code, this is the trickier direction. If I run the server code on here, the question is, can I get to it from my VirtualBox? Right, and apparently I can. So you can use localhost, right, if you're just on one machine, which is how you can develop PA5. Just go from machine to machine, use localhost or 127.0.0.1. If you want to go from one machine to another, you need to know the destination address on whatever network that machine is on. And then the really super... the trickier part is going from machine to machine, but so if I run server to server, what was my IP address here? 10.0.2.15. So I don't think I can tunnel in to my VirtualBox from outside my VirtualBox because it's, you know, localized. But I can certainly go from inside my VirtualBox to my VirtualBox. And local address will actually still work on that localhost. Let's see what I missed in chat here. Has virtual ports, need to talk. I think there's a sword in nature. Or cats with swords. Alright, cool. Alright, so, all of that aside, here's where this leaves us. We can open up, you know, a server socket on this side. We can create a socket on the client side, and we can say connect to it. And for what you're doing for PA5, that's all you really need to worry about. Okay, we're going to send messages in a very controlled way. We know exactly when one side's going to send a message. And the protocol I suggested in the assignment was, you know, so here's your server, here's your client. You got to know which one is which. So step 1, open a server socket. Step 2, connect to the server socket. And you can define this a number of ways, but step 3 could be send player 1 name. Step 4 would be receive player 1 name, and then send player 2 name. And then step 6 would be receive player 2 name. And then we enter kind of a round robin thing, which is when we get a mouse click, we send the coordinates of that click to the client, and over here we receive the click information from the server, and then do nothing until we get a mouse click, at which point we send that click and we go back up here. On the server side, we wait for a mouse click, we send it, and then we receive a click from the client. And then we go back up there. So we have the server side and the client side, and the server is player one, they go first. And it's really important you establish that order up front so you don't have to wait to see who's going first. So server is going first. Nothing happens until you get into your mouse listener. You click, you get the XY coordinates, send that to the client, right? And the client, every time that it receives a click information, it just passes those XY's coordinates to your code that would normally handle a mouse click. And so it acts like somebody came over and grabbed your mouse and clicked it, except it was somebody on a remote machine, but your code is calling the same click handler. Yeah, so what could go wrong? And then, you know, anytime that the client clicks, you send those coordinates over to the server. And if you've got PA4 working correctly, right, if we're waiting for the server to click and the client goes ahead and clicks, you'll go ahead, you'll send that over, your server will call the click code, but it should say, you know, not your turn. Or, you know, don't send it at all. Detect over here when you get the click before you send it, check to see whose turn it is. If it's not the client's turn, say, you know, it's not your turn, and don't bother sending the click information. And how do you know when it's the client's turn? Because eventually the server, the person on that side, will click their mouse. Their code will say, yeah, it's the server's turn. It'll send that information over to you, and your code that receives the click after it calls a mouse handler, your mouse handling code says, you know, if you didn't complete a box, switch whose turn it is. And so now it'll be the client's turn, and the next time that you click, your code is happy, it's a legitimate click, it'll go ahead and send the coordinates over, and so on. And then every time that you receive something, check to see if it's a quit message. And so you need to establish some kind of communication protocol. And this is spelled out in more detail in the afternoon lecture from Friday, which I suggested you watch. But you need some kind of protocol for passing information between these two pieces. So one suggestion was, you know, in the very beginning, you're going to exchange player names. And so we always know the first thing that's going to happen is you know, maybe the client will send its player name and the server will send its player name. And you establish the order in which that's going to happen, so you're not both waiting, you know, for the other person to send first and so on. And then your standard message is just XY coordinates. And so the protocol I showed Friday, right, I just said X followed by X coordinate, Y followed by Y coordinate. You could send, you know, a C followed by X and Y. You could put them in parentheses. It's up to you, right? Something that's easy to code and easy to look at and understand. And then, you know, a special message like a Q or quit or something like that, which says, hey, we're terminating the game. And when the game terminates, it exits right there, and you don't have to, you know, restart or anything like that. Don't have to get confirmation. You can just quit. So you set up some kind of communication protocol so that you can do these exchanges, and you're off to the races. So that should be everything you need to know to do PA5. And like I say, it's really just kind of tapping into PA4. So specific changes, right? So you definitely need to decide ahead of time who's the client, who's the server. And that's really hard to kind of handshake your way into, because somebody has to initiate the conversation by, you know, creating a socket that can listen for a connection. So have some radio buttons to say, am I the server or am I the client? And just understand that when two people want to connect, they have to have decided, you know, which one's going to be which. And you need exactly one of each. server is player 1 goes first, client is player 2 goes second. So fix that for eternity. If you're the server, have a button that you can use to create the server socket and listen for connections. Let them put in player 1 and make sure that player 1 has a name when you start the game, and if they don't put in a name, just change the name to be server. Right, so fill that in automatically. And set your flag for whose turn it is to be player 1. On the client, once they hit the radio button saying I'm the client, they also need not just a connect button, but a button to say who do I want to connect to, so they can put in the name or IP address of the server. They have a field that they can type in their player name on and go ahead and have a connect button. When they hit connect, it should create a socket, try to bind it to the address port 1234, and establish a connection. When they try to connect, if they haven't put in a name for player 2, set that name to client. Okay, so that you can run this without having to type in names. You can just hit server on one side, start, and connect on the other, and it'll go ahead and connect up. Also, the host ID default value is localhost. Okay, so you can put that in the box to begin with. And these defaults, right, I mean, you can just make the default server, or you can change it to server, you know, when they hit the start button and so on. Once they either hit the start button to make a server or a connect button to connect to the server, change those buttons to say quit. That's how you end the game. And then basically swap your names and go into this whole loop where you wait for mouse clicks. And somewhere you have a mouse listener, which is called when you get an XY coordinate. And if you did everything inside that mouse listener, you probably want to take most of what you do in there and change it into a method that you can call with XY coordinates and have it do everything. So in your mouse listener, now you just call your method with, you know, event.getX, event.getY. But then when you have this other thing, which we're going to talk about, that's receiving clicks from the other side, go ahead and take the XY coordinates you received and call that same method, right, to emulate the behavior of a mouse click. All right, so questions about that? Okay. All right. So that's PA5. So for PA5, we know what the order of communication is, right? This is what I call moving in lockstep. So we know when we're expecting to receive a message from the server, and we can just hang out and we can have something that's waiting to receive that click. But let's think about a different situation. Imagine, if you will, a situation where you have a server and you have a client, and you want to have like a chat program. So someone on this end can type messages, and every time they hit enter, the client sees what they typed. And the client can also type in messages, and every time they hit enter, the person on the server side sees what the client typed. And you have this two-way communication going on. Now, if we did this exactly like we're doing in PA5, if we said, okay, first you can type a message, and the client will see it, and then the client can type a message, and the server will see it, and then the server can type a second message, and the client will see it, right? We could do this exactly the way that we're going to do PA5. We could just, wait for a message over here, and when we get it, we could send a message, and so on and so forth. But, with a chat program, the server might get really chatty and type in 15 messages while the client is typing in one message to send and hasn't even hit enter once. And so we can have both of these streams running asynchronously. And this creates a challenge. So if we're moving together, what would the server do? It could read standard in, send to client, read from client, send to standard out, go back up to the top. If the server's starting, what would the client do? Read from server, take what the server sends, send that to standard out, and then use your scanner to read from standard in, send that out to the socket so the client, so the server gets it, and go back up. But you can probably see the problem here, which is if I'm sitting right here waiting to read from standard in, the server could be sending me a bunch of messages, but until I finish reading from standard in and I send my message to the server and I come back up here to read from the server, I'm not going to see anything the server is sending. So this only works if you're taking turns sending and receiving, and you're doing that in perfect unison, which for PA5 is fine. But in a more general setting, that's not going to work. So we need to do something different. And so this gets us into the idea of threads. Because what we really want to do is the following. And this is the last time I'll say it. This is not something you need to worry about too much if you know how things are moving. But we're going to have to do this in PA5 anyway because we're using swing, and swing is running as a thread. But here's what this looks like in a chat program. So our server creates a pair of processes. Process 1 says read standard in, send to the client, and then go back up to the top. Process 2 says read from the client, copy that to standard out, and go back up. And then on the client side, we have a pair of threads. Thread 1 says exactly the same thing. Read from standard in, send to the server, go back up, and thread 2 says read from the server, copy that to standard out, go back up to the top. So now we've got 4 threads running. And this thread, its only job is to take what you type and send it to the client. And totally independent of that, we have a separate thread which is just waiting for information from the client and displaying it to you. So while I'm in the middle of typing something here, if the client sends me a message, this thread will ingest it, send it to standard out, and I'll suddenly see that appear on my screen even though I'm in the middle of typing something. And the client can spam me with, 100 messages, and this thread will just keep reading those messages, displaying them to my screen before I've even sent a single message. And the same thing on the client end. So for this kind of setup for a two-way chat system, we need to deal with threads so that we don't block when we're trying to read standard in and prevent, some part of our code from receiving information from the other side of the connection. So what does this look like in PA5? So swing runs as a thread basically, right? This is why our main program can exit, or we can be doing something else, and you know, the program doesn't go away. And if you click a mouse, eventually some piece of your code gets called, or if a window gets resized, eventually your paint method gets called. So you already have a thread running in the background that's taking care of all of your swing things. So my suggestion is to make a network thread, and the whole purpose of the network thread is basically receive an XY pair and call my click handler. But only if, well, you just call my click handler. So this can hang out here, and you know, you don't want to make a while statement which sits there and waits for a message to come in from the other side of the connection. You never want to have, like, you know, an infinite while loop inside something that's working with swing or anything else that's threaded like that. Because if you sit in a while loop, your events won't get handled if you resize your window. If you click somewhere, swing's not going to notice it. It's not going to respond to it. So everything is still event driven, right? But we can make a separate thread that will hang out and say, you know, read from my scanner, which is connected to this socket, and you know, once has next line is true, get the next line, parse it out as an XY pair of coordinates, call my click handler. And the only time that you should get a message from the other side of the connection is when they've clicked the mouse and it was a legitimate click, meaning it was their turn, and so their code sent you that XY pair, or they send you a quit message. So this thread can safely hang out, and it can block, it can wait inside a, you know, while scanner.hasNextLine call, and then pick up that line and so on. But you can also put a method in here, like sendXY, which when you click your mouse and it's a legitimate move, it's your turn, and you go ahead and you call your click handler to, you know, draw the line, fill in the box, and so on. You also call this method so that you send that XY click information to the other side of the game, the other point of the connection. And this network thread is going to do the thing like, you know, create the socket or the server socket, depending on if you're the client or the server. And, you know, make the print writer and the scanner and try catch blocks and all of that stuff, right? Put that all inside this net thread. And then go ahead and make yourself a method for sending stuff, and make yourself a loop so that when this thread is running, it basically receives information from the other side and responds to it accordingly. All right, so so questions about that structure so far? We have to talk about the mechanics of doing threads next. This is definitely one of these things that takes a while to get. but as you start developing this layer on top of PA4, it will start to click / more questions will become more obvious. All right, so let's talk about the mechanics of doing threads. So we talked a little in 224 about the fork call and execl and execve and some of these things for creating processes in C. Most languages have some notion of creating multiple processes and tying them together. And there's a few different ways to do this in Java, but the easiest way is to work with threads as a class. So thread is a class. An execution in a thread of execution in a program allows an application to have multiple threads of execution running concurrently. The main thing we're going to do is we're going to create a new class that extends a thread. All right, and threads, there's not a whole lot going on in there. There's a few ways to construct them, and there's not that many methods. The main method we're interested in is something called run. All right, so let's just write something. Alright, so I'm going to make a main program here. And so I'm going to create an object of type myThread. I'm going to just call this MT1. And let's define what that looks like. So what should myThread do? Let's go ahead and let's make a method in here. I'm going to call it run. And I'm going to make a constructor in here so I can identify my threads. We're going to run out of time really soon here. So let's make an ID of this thread. So I'm going to construct the thread. I'm going to pass an integer to the constructor. I'm going to save that integer I use in the constructor in this field called ID, and let's go ahead and let's just print out the ID followed by this integer that we're going to iterate over 1,000 times, and let's construct a thread. So we'll construct 3 threads. And let's go ahead and run these things. How do we do? All right. I did, thank you. All right, so this does exactly what we would expect, right? It runs that first method, and it iterates 1,000 times, and then it calls mt2.run, which iterates 1,000 times with an ID of 2, and then it calls mt3 with an ID of 3. All right, and we get cool patterns, right? It's called moire patterns. So what we'll do tomorrow is we will change this, and we'll make all 3 threads run simultaneously. And it's going to be really easy to do that. We're going to have to do 2 changes to make that happen. So we'll do that, and then we'll start digging into the gory details of threads. All right, cool. I will call it good for there. And I will stick around a couple of minutes to talk to 2 people I said I was going to talk to after class. Otherwise, have a good afternoon. I will see you tomorrow.